Hi, I'm Jerry Zhang, a teaching assistant for this class. You can call me Jerry. Today we will look at some problems about homework 2. For this first problem, we need to determine how much of the water column is due to the surface tension effect. That means we need to calculate the capillary rise. So from the Professor DeBlau's lecture, we know that the delta H equals 2 times sigma, the surface tension, over the gamma times the radius times cosine theta. And we know the radius equals diameter over 2, so we can get that delta H should be equal to the 4 times sigma over the gamma times d times cosine theta. For the cosine theta, for the case of water inside a clear glass tube, we assume that the theta equals 0, so we can determine that cosine theta equals 1. So now the delta H should be equal to 4 sigma over the gamma times the d. When the problem didn't give us the water temperature, we always assume that the water temperature is 10 degrees Celsius. So T water is 10 degrees Celsius. And at this temperature, gamma sigma equals 0.005 pounds force per feet, and the gamma equals 62.4 pounds force per cubic feet. And you can find these two values on the appendix table of your textbook, or you can find these values online. So now we can get that the delta H equals 4 times 0.005 pounds force per feet over 62.4 pounds force per cubic feet times the d feet. And this value is 3.21 times 10 to the power of negative 4 square feet over the d feet. And from the problem, we know that when d equals 1 over 2 inch equals 1 over 24 feet, the delta H should be equal to the 3.21 times 10 to the power of negative 4 square feet over 1 over 24 feet. So this value is 0.00769 feet equals 0.0923 inch. And when d equals 1 over 8 inch equals 1 over 96 feet, we can get that the delta H should be equal to 0.0308 feet equals 0.369 inch. And when d equals 1 over 16 inch equals 1 over 192 feet, we can get that the delta H equals 0.0615 feet equals 739 inch. So this is the third H value. So we finished this problem. So for the second problem, A, we need to derive algebraic equations for the mechanical advantage. And B, we need to calculate D1 and D2 so the mouse can support the elephant. Let us first to do the A. To find mechanical advantage of the hydraulic machine, we can apply the force equilibrium to each piston. So for the mouse's piston, we know the force F1 on the piston equals the weight of the mouse equals P1 times A1 equals P1 times pi times D1 square over 4. So we can get that the P1 should be equal to the W1 times 4 over the pi times D1 square. This is equation 1. And for the elephant's piston, we know the force on the piston F2 should be equal to the weight of the elephant. W2 equals P2 times A2 equals P2 times pi times D2 to the power of T2 square over the 4. And we can determine that P2 should be equal to the W2 times 4 over the pi times D2 square. This is equation 2. And we recognize that the piston at the same elevation, so we know that the P1 should be equal to P2. And combine equation 1 and the equation 2, we can get that W1 times 4 over pi times D1 square should be equal to W2 times 4 over pi times D2 square. And we can get that W2 over W1 should be equal to D2 over D1 to the power of 2. So this is an algebraic equations for the mechanical advantage. And now to solve B2, to solve B, and we know the mass of mouse M1 equals 25 gram, so equals 0.025 kilogram. So we can get that the weight of mouse should be equal to the M1 times C equals 0.025 kilogram times 9.8 meters per second squared. And we also know the mass of elephant W2 equals 7,500 kilogram. So we can get that the W2 should be equal to the M2 times C. So we know the W2 equals 7,500 kilogram times 9.8 meters per second square. And now we know that W2 over W1 should be equal to 7,500 kilogram times 9.8 meters per second square over 0.025 kilogram times 9.8 meter per second squares. So we know W2 over W1 should be equal to the 300,000. So now we know W2 equals over W1 should be equal to D2 over D1 to the power of 2 equals 3 300,000. So that means the ratio of D2 over D1 should be equal to the square root of 300,000. And now we can show that the D1 equals 70 millimeter. So we can get that D2 should be equal to the 38.3 meters. So you can show the other values for D1, and you can get other values for the D2. So we finish this problem. For the third problem, we need to determine the specific gravity of the oil and the pressure rating on gauge C. So to find the oil specific gravity, we can apply the hydrostatic equations from A to B. And now we assume that the datum is surface B. So according to the hydrostatic equations from oil surface to elevation B, we have that the PA plus gamma oil times ZA should be equal to PB plus gamma oil times ZB. From this figure, we know that the PA is 50 kilopascal and equals 50,000 Newton per meter squared. And as ZA should be equal to the 1 meter. This is ZA. And the PB is 58.5 kilopascal, is 58,500 Newton per meter squared. And the things we assume that the surface B is datum, so the ZB is 0. So now we can get that the gamma specific weight of the oil equals 8,500 newtons per cubic meter. And now we still can determine the specific gravity of the oil. So the specific gravity of the oil should be equal to the gamma oil over the gamma water at the 4 degrees Celsius. And we know the gamma oil equals 8,500 Newton per cubic meter. And we can determine the gamma water at 4 degrees Celsius on the appendix tables of your textbook. So this value is 9,807 Newton per cubic meters. So we can know the specific gravity of oil should be equal to the 0.87. And to determine the pressure rating on gauge C, we still need to apply the hydrostatic equations in water. And now we assume that the datum is surface C. And we know the PC should be equal to the pressure at the bottom of oil plus gamma water times ZC. And from this figure, we know the P, the pressure at the bottom of oil, should be equal to the PB plus 0.5 times gamma oil. Yeah, so the pressure at bottom of the oil should be equal to the PB plus 0.5 times the gamma of oil. And we know the PB is 58,500 Pascal plus 0.5 times 8,500 Newton per cubic meter. And we know the water temperature is 10 degrees Celsius. So we can determine that the gamma water is 9,810 Newton per cubic meter. And the ZC should be equal to 1. This distance is ZC. So now we can determine that PC should be equal to 58500 Pa plus 0.5 times 500 Newton per cubic meter plus 9,810 Newton per cubic meter times 1 meter. So we can determine that the PC should be equal to 72560 Newton per meter squared, and equals 72.56 kilopascal. So we finished this problem. For the first problem, we need to determine the magnitude of the force F2 resistant by the piston. And for the piston 1, we know that F1 should be equal to P1 times A1, and we can get that the P1 should be equal to the F1 over A1 equals 4 times F1 over pi times D1 squared. And from the problem, we know that F1 is 390 Newton, and so D1 is 4 centimeter, is 0.04 meters. So now we can determine that the P1 should be equal to the 3.0352 Pascal. And then we will apply the hydrostatic equation, and we assume this surface is Dayton. And we have that P1 plus gamma oil times Z1 equals P2 plus gamma oil times Z2. And we can get that so P2 equals P1 plus gamma oil times Z1 minus Z2. And we know the P1 equals 310,352 Pascal, we calculated before. And we know the gamma oil should be equal to the specific gravity of oil times the gamma water at the 4 °C. And from the figure, we know the specific gravity of oil is 0.85. And we know the gamma water at 4 °C is 9807 Newton per cubic meter. We can find this value online on the appendix table. And since this surface is at the datum, so Z1 is 0 and Z2 is 2 meters. So now we can determine that the P2 should be equal to 293,680 Pascal. And now for the pistol 2, we know that F2 should be equal to the P2 times A2, and it equals P2 times pi times D2 square over 4. And we know P2 equals 293,680 Pascal. And the D2 equals 10 centimeters equals 0.1 meters. So we can get that the force at pistol 2 F2 should be equal to 236.6 Newton. So we finished this problem. For the fifth problem, we need to determine the pressure at center of pipe B. First, we assume this is point A, this is point C, this is point D, and this is gamma 1, this is gamma 2. To solve this problem, we need to calculate the pressure from point A to point B. The Professor Diblas in the lecture told us that how to calculate the pressure at a given point. But first, we need to identify a reference point and the pressure values at that reference point. So for this problem, we first choose A as a reference point, and we are interested for the pressure at the point C. And we know the point C is at a lower elevation, so we need to add the positive gamma times H. So now the PC, the pressure at C, should be equal to the PA plus the gamma times the gamma 1 times HAC. And since we know the distance of this part is 50 centimeter, and then we also know the slope is 3/4, so we can determine this vertical distance HAC should be equal to 30 centimeter. And now we choose point C as reference point, and we want to know the pressure at point D, and we know the point D is a higher elevation, so we need to add the negative gamma times H. So now the PD should be equal to the PC minus the gamma 1 times HCD. And from this figure, we can determine that HCD should be equal to the 10 centimeter. At the last, we need to determine the pressure at the center of the pipe B. And we know the point B is higher than the point D. So we need to add the negative gamma times H. So the PB should be equal to the PD minus gamma 2 times HBD. And from this figure, we know HBD should be equal to the 50 centimeters. And we know the PB equals PD minus gamma 2 times HBD. And we also know the PD equals PC minus gamma 1 times HCD. And the PC equals PA plus the gamma 1 times HAC. So now we can get that, the PB should be equal to the PA plus the gamma 1 times HAC minus the gamma 1 times HCD minus the gamma 2 times HBD. And since the point A is open to the atmosphere, so the PA should be equal to 0, and the gamma 1 equals 20 kilonewton per cubic meter equals 20,000 Newton per cubic meter, and the gamma 2 equals 10 kilonewton cubic meter equals 10,000 Newton per cubic meter, and HAC equals 30 centimeter equals 0.3 meters, and HCD equals 10 centimeter equals 0.1 meter, and HBD equals 50 centimeter equals 0.5 meters. And now we can get that the PB should be equal to the negative 1000 Pascal. In addition, you can also use manometer equation to solve this problem. The manometer equation is P2 equals P1 plus sum of down gamma I times HI minus sum of gamma I times HI. You can still use this equation, directly use these equations to solve this problem. And this equation is the equation 3.21 on the page 73 on your textbook. So we finished this problem. For the last problem, we need to determine the pressure at the center of pipe. So the method for this problem is very similar to the previous problem. So I will directly write the equation. And we'll show this is point B, and this is water 1, and this is water 2. So the PA should be equal to PB plus the gamma water times H water 1 plus the gamma mercury times H mercury minus the gamma oil times H oil plus the gamma water times H water 2. Since point B is open to the atmosphere, so the PB should be equal to 0. And we know the temperature, water temperature is 10 degrees Celsius. So the gamma water should be equal to the 9810 Newton per cubic meter. And we know the specific gravity of mercury is G. Mercury should be equal to the gamma mercury over the gamma water at the 4 degrees Celsius. So we can determine that gamma mercury should be equal to the Sg mercury times the gamma water at 4 degrees Celsius. And from this figure, we know this value Sg of mercury is 13.6, and the gamma water at 4 degrees Celsius should be equal to 9807 Newton per cubic meters. So we can determine that the gamma mercury should be equal to 1333 75.2 Newton per cubic meter. Similar to the Sg oil, so Sg oil should be equal to gamma oil divided by the gamma water at 4 degrees Celsius. So we can determine that the gamma oil should be equal to Sg oil times the gamma water at 4 degrees Celsius. And from this figure, the Sg oil equals 0.8 and times 9807 Newton per cubic meter. So we can get that the gamma oil should be equal to 7845.6 Newton per cubic meter. And then we know the H water 1 is 90 centimeters equals 0.9 meters, and the H water 2 equals 150 centimeter equals 1.5 meters. And H mercury should be equal to 30 centimeter plus 30 centimeter equals 60 centimeters equals 0.6 meters. And H oil should be equal to 30 centimeters plus 150 centimeters equals 180 centimeters equals 1.8 meters. So now we know all of these values, so we can determine that the PA should be equal to 89.4 Pascal. So we finished this problem.